The last examples I'm going to do from this section are on page 220, homework problems 43 to 46. They give you two graphs. The first graph they give you is the graph of the function y equals f of x. And the second graph they give you is the function y equals g of x. And then 43 through 46, they give you 8 different combinations that they want you to perform using the information from these two graphs. So 43a says to perform f plus g of 3, which is f of 3 plus g of 3. So f of 3, so I go 3 for the f graph, then I go up, is 2. G of 3, go 3 on the g graph, then go up, and that gives me a 1. So I have 2 plus 1, and the final answer for 43a would be 3. 43b says to find f over g of 2, which we know is f of 2 divided by g of 2, provided that g of 2 is not 0. So f of 2 is 0. G of 2 is 2. And the final answer is 0. Next one, they want me to find the difference of f and g evaluated at 1. F evaluated at 1 is the number 2, minus g evaluated at 1, which is 3. And 2 minus 3 is equal to negative 1. 44b, it's the product of f and g evaluated at 4. So f evaluated at 4 is 4. G evaluated at 4 is 0. And 4 times 0 is 0. And the last 4 we're going to perform are function compositions. And remember, it means to perform the functions in right to left order. So the first thing I want to do is I want to find f of g of 2. So I need to find out what g of 2 is. Well, g of 2 is 2. So I now want to find f of 2. I put a 2 into my original function f, and I get 0 for its output. So 0 would be the answer of f composed with g evaluated at 2. Next, I want to do g of f evaluated at 2. So I'm going to write g of f evaluated at 2, where I need to find f of 2. Well, if I put a 2 in for f, I get 0, which tells me I want to now find what g of 0 is. And g of 0 is the value 4. And again, a reminder, order does matter when composing functions. Next, f of g of 1. I'm going to write that as f of g of 1. Going to now evaluate what g of 1 is. G of 1 is the number 3. So I now want to find f of 3. F of 3 is 2. And the final example is g of f of 3. So I want it g of f of 3. I put a 3 into my f function, and I get a 2. So I now want to find g of 2. I put a 2 into my g function, and I get a 2. So now you should be able to use graphs to combine functions arithmetically and using function composition. You should be able to do it just writing them in function notation and providing input values for each of the functions.